So this is a half-wave rectifier circuit. We have discussed this rectifier circuit, its construction, how the connection takes place, and its working in the last lecture. So let's have a glance over here of half-wave rectifier. Half-wave rectifier contains a single diode, so that we could able to get only half of the input signal at the output side. So it is called as a half-wave rectifier. Any rectifier circuit need to convert AC signal, input is AC and output expected is a DC one. Um, as there are two types of rectifiers, half wave rectifier and full wave rectifier. Half wave rectifier is not successfully uh, able to convert whatever AC signal provided at the transformer side to 100% pure DC signal. So whatever output signal we get at the rectifier, it is called as a pulsating DC. This term we have already discussed. So pulsating DC means what? It is not a DC, it is not a AC, but it is in between that. Maximum DC would be there, but AC components are also present in the output. So 100% हमें expected output नहीं मिलता. AC plus DC combination is called as a pulsating DC. So this is about the transformer. Someone has unmuted. Please mute yourself because I'm getting the sound from side. Uh, Ajay Ghosh, please mute yourself. Ajay. After that, these waveforms are important. एग्जाम में ऐसे क्वेश्चन आएगा कि explain the working and the construction of half wave rectifier. In that case, you need to draw the circuit diagram. See how the connections takes place. Write down the working for positive half cycle and for the negative half cycle separately. You can mention the advantages and disadvantages also. Advantages and disadvantages हम वहाँ पे discuss करेंगे. Now this analysis part में हम circuit का analysis करेंगे where we are able to get the equations. With the help of that we can solve the numerical section. Time being आप numerical पर इतना concentrate मत करो, only theoretical part पर आप concentrate करो. यूनिवर्सिटी एग्जाम में ना ही आपके यूनिट टेस्ट में न्यूमेरिकल से रिलेटेड कुछ भी पार्ट आएगा फॉर योर बैच ओनली. आप थेरी पर ज्यादा कॉन्सेंट्रेट करना, ठीक है. वर्किंग ऑफ हाफ वेव, फुल वेव एंड ब्रिज रेक्टिफायर एंड वट एवर थेरोटिकल पार्ट इज देयर. न्यूमेरिकल रेक्टिफायर से रिलेटेड थोड़ा कम वेटेज दे दो उसको. शायद ओरल एग्जाम में आपको पूछ सकते हैं कि व्हाट इज द इक्वेशन टू फाइंड आउट द डीसी करंट फॉर द हाफ वेव रेक्टिफायर. सो यू शुड नो कि आईडीसी इज इक्वल टू आई एम बाय पाई. ओके, उस एंड में हम तीनों सर्किट जो हम स्टडी करने वाले वी आर गोइंग टू कंपेयर with all the points जिसका आप चार्ट बना के आपके रूम में पेस्ट कर सकते हो, so that it would be easier for you to read the equations daily and वो आपको by heart हो जाएंगे. So IDC stands for DC current. DC, this is a term related to the output side, because AC it is a term which comes from the transformer. So AC हमारा input है rectifier को and DC जो है वो हमारा output है. So remember whatever DC terms there in any equation, that DC term it is related to the output side of the circuit. So IDC stands for output current, output DC current. इसका equation है Im by pi, where Im stands for maximum current. Maximum current can be find out by using Ohm's law. I is equal to V upon R. So Im is equal to Vm upon RL, where RL stands for load resistance. ये हमने कल देखा है. The same way we can find out the equation for VDC. This is the output DC voltage. Equation is Vm upon pi, where Vm is a maximum voltage, or we can say it is a peak voltage. Then IRMS, root means square current, Im by 2. This is the equation. VRMS, Vm by 2. This is the equation. Ripple factor, यहीं तक हमने कल I think हमारा हो गया था. Now this term is if you are not unmuting yourself, I need to remove you from the meeting. So please mute yourself. Otherwise, I will remove you. Okay, so ripple factor, it is indicated as a small r. So remember, what is the purpose of the rectifier circuit? The purpose of using the rectifier circuit is to convert the AC into the DC signal. The output of any rectifier contains AC as well as DC components. No rectifier, even full wave rectifier, it is not 100% successful in conversion of AC into DC. So कोई भी rectifier हो उसमें AC component output में present होता ही होता है. हाफ वेव रेक्टिफायर में AC थोड़ा ज्यादा होगा, फुल वेव रेक्टिफायर में थोड़ा कम होगा. But in any rectifier circuit, the output of that circuit contains AC and DC components both. The ripple factor actually measures the percentage of AC component present at the output of rectifier. The ripple factor indicates how close the rectified output is to the pure DC voltage. That means small amount of ripple factor means small amount of AC, that means larger amount of DC is present. So we always want ripple factor at a minimum level. The ideal value for ripple factor for any type of rectifier circuit is it should be 0, because ripple means कि हमें कितना AC output में मिल रहा है जो हमें नहीं चाहिए. So ideally the value of ripple factor should be 0, but practically कुछ ना कुछ होता है, but practically it should be as small as minimum as possible. Okay. So remember, ripple factor indicates the amount of AC component present at the output of rectifier. We want always ripple to be at a minimum level because ripple indicates the unwanted part that is present at the output. To find out the ripple, how much amount of ripple is present, we have the equation ripple factor is equal to RMS value of AC output upon DC output. So यहाँ इक्वेशन में इसको डालना VRMS स्क्वायर माइनस VDC स्क्वायर रेज टू हाफ, बिकॉज दिस इज अ रूट मीन स्क्वायर अपॉन VDC. VRMS का इक्वेशन है VM/2, उसको स्क्वायर किया. VDC का इक्वेशन है VM/π, उसको स्क्वायर किया. देन इट इज 1/2. डिनोमिनेटर VDC इज इक्वल टू VM/π. उसको सॉल्व करके प्रॉपर उसका अरेंजमेंट करके द रिपल फैक्टर फॉर half wave rectifier we are getting R is equal to 1.21. This is a figure we get. This is a number we get. That indicates the ripple factor for half wave rectifier is 1.21 times the DC component. This value of R, it is very high for the half wave rectifier which contains higher amount of AC present. So as the ripple amount is very high, that means this half wave rectifier is not faithful, not successful in conversion of AC into the DC. So this circuit is very rarely used, not used generally, but study के लिए सिर्फ इसको use करते हैं. So ripple factor of half wave rectifier, remember you need to remember this figure 1.21, क्योंकि इसको एग्जाम में भी पूछ सकते हैं कि what is the ripple factor for half wave rectifier, what is the efficiency for half wave rectifier, and the same factors for the full wave also. Okay, so you need to here uh, 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 concentrate on R factor. Ripple factor is 1.21. This is one of the disadvantages of half wave rectifier is that ripple factor is very high. That means the amount of AC present at the output of half wave rectifier is high. So this circuit is not used for the conversion of AC into the DC. Next analysis part, next analysis, we can say parameter is DC output power. So DC term, it is related to of course output power, that is P. So PDC is equal to I square DC into RL, I square into R. This is the equation to get the power. I square DC, IDC we know IM/π. So I square DC होगा IM square upon pi square. IM को भी हम replace कर सकते हैं V upon RL. Okay, and by after placing the respective values we get the two equations to find out the DC power for the half wave rectifier, that is equal to V square DC upon RL. P is equal to V upon R. ऐसे भी आप simple equation याद रख सकते हो. So P is equal to V square upon R. So PDC is equal to V square DC upon RL. करंट में आप उसको कन्वर्ट करो, V is equal to IR होगा. So by Ohm's law, you can replace V by IR. Next parameter is AC input power. I remember the term AC is there. So this is AC input power for the half wave rectifier that is related to the secondary windings of the transformer. ये PAC का हमें formula मिला Im square upon pi upon 4 in bracket RS plus RF plus RL, because as we are talking about from the input side, so we need to consider the resistance of the secondary winding of the transformer, then forward resistance of the diode and the load resistance. By comparing the value of RL with RF and RS, RF and RS, these values are very, very small as compared to the load resistance value. So we can directly neglect these two values. तो RF और RS को अगर हम neglect करें तो हमारा सिर्फ RL टर्म यहाँ पर बचता है. So at the end we could able to get PAC is equal to Im square into RL upon 4. Okay, so this is about the PAC for the half wave rectifier. Next is rectifier efficiency. This point is very important for your examination. Remember PAC के बाद efficiency है. Efficiency indicates a minute. Efficiency is indicated as eta. So rectifier efficiency is defined as it is a ratio of output power upon input power. So any term output upon input, it is called as a efficiency. As we are talking about the rectifier efficiency in terms of power, we can define the rectifier efficiency eta is equal to output power, which is expected as a DC, upon input power, which is the AC power. So we can say that efficiency is equal to output power PDC upon input power PAC. ठीक है. PDC का हमने यहाँ पर इक्वेशन डाला. P is equal to what we can write I square into RL. Okay, I stands for Im upon pi. So उसका square upon PAC. Input again denominator में RL plus RF plus RS लिखा है, उसको neglect करो, सिर्फ RL बच जाएगा. So numerator RL and denominator RL will get cancelled. We left with only two terms, 4 upon pi square, and the value of eta, that is efficiency for the half wave rectifier, which always represented in the terms of percentage. So percent efficiency is equal to 40.5%. This is very important point. The efficiency for half wave rectifier is 40.5%, nearly equal to 41%. So rectifier efficiency indicates the percentage of AC input power which is actually converted into DC power at the output. So efficiency of any circuit should be very high. Ideally, it should be 100%, but practically it should be very close to the 100%. Lower efficiency matlab circuit is not successful in the conversion of desired output. So half wave rectifier का efficiency है जो है, this is less than 50%. That means this circuit is not, I mean, faithful, not that much good to convert the AC input power, AC input signal into DC output signal because it has lower efficiency. Remember, the efficiency for half wave rectifier is only 40.5%, which is very low. Ideally, it should be 100%. ओके ये भी आपको एग्जाम में आ सकता है कि व्हाट इज एफिशिएंसी. आई थिंक आपने जो प्रैक्टिकल परफॉर्म किया ना, उसमें जो क्वेश्चन से नीचे आपके राइट अप में, उसमें शायद ये दो पार्ट्स है, रेक्टिफायर इफिशियंसी एंड द ट्रिपल फैक्टर. You please check from your side. Next is transformer utilization factor. This is also important. This factor tells us how well the transformer it is being utilized by the rectifier circuit. Ideally, this factor should be very high. It should be 100%. Practically, वो थोड़ा ज़्यादा चाहिए. Now, transformer utilization factor, it is defined as it is a ratio of DC output power to AC power rating of the transformer. So, transformer utilization factor is equal to output power PDC upon AC power rating of the transformer. That is equal to VDC into IDC at the numerator upon VRMS into IRMS at the denominator. VDC का इक्वेशन है Vm by pi, IDC का इक्वेशन है Im by pi, VRMS का इक्वेशन है Vm by 2, IRMS का इक्वेशन है Im by 2. तो ये पूरे प्लेस किए इक्वेशन के अंदर. देन जो रिपीट टर्म्स है Vm from numerator and denominator, Im from numerator denominator, they will cancel each other, and at the end we'll get the transformer utilization factor in percentage as 28.7%. That indicates a transformer utilization factor for half wave rectifier is only 29%, which is very small. That means only 28% transformer it is been utilized out of its full capacity. कितना होना चाहिए ideally? It should be as high as possible. It should be 100%. So transformer utilization factor should be as high as possible. For half wave rectifier, this factor is very low. This indicates that transformer is only utilized to 28.7% of its full capacity. This is one of the disadvantages of half wave rectifier. कि ट्रांसफॉर्मर ओनली 28-29% ही यूटिलाइज होता है आउट ऑफ 100%. ओके. Next parameter is peak inverse voltage. Now let's see what is mean by peak inverse voltage. Peak inverse voltage, this is actually the voltage that appears across the diode when the diode is in a reverse bias state, when the diode is in a non-conducting state. So this is the maximum reverse voltage that appears across non-conducting diode. For example, सपोज पॉजिटिव हाफ साइकिल के लिए डायोड फॉरवर्ड बायस में इट एक्ट्स एज अ क्लोज स्विच, करंट फ्लो हो गया. बट नेगेटिव हाफ साइकिल में डायोड एक्ट्स एज अ ओपन स्विच, नॉन कंडक्टिंग स्टेट में. सो व्हेन द डायोड इज रिवर्स बायस, उसके अक्रॉस कितना वोल्टेज आ रहा है, दैट इज इंडिकेटेड बाय पीक इनवर्स वोल्टेज. फॉर हाफ वेव रेक्टिफायर द पीक इनवर्स वोल्टेज इज इक्वल टू Vm, दैट इज मैक्सिमम वोल्टेज. क्योंकि वही है ना, हमारा जो सिग्नल है, इनपुट सिग्नल, दैट गोज टू द प्लस Vm एट द पॉजिटिव साइड एंड माइनस Vm एट द नेगेटिव साइड. तो डायोड जब नॉन कंडक्टिंग स्टेट में है तो मैक्सिमम वोल्टेज वो कितना कैरी कर रहा है, इट इज Vm एट द नेगेटिव साइड. सो पीक इनवर्स वोल्टेज for the half wave rectifier is equal to Vm. This is the maximum reverse voltage handling capacity of the diode when it is in a reverse bias state. Then regulation. Regulation ये आपके syllabus में नहीं है, but still if you want you can define this term. Regulation is defined as it is a percent change in the load voltage with respect to its full load voltage. Percent regulation is VNL minus VFL upon VFL into 100. Next parameter, the last parameter is output frequency. The output frequency of the signal for half wave rectifier is equal to the input frequency. So F out stands for output frequency of the signal is equal to F in, that is input frequency. Okay, so these are the parameters we have seen for half wave rectifier. Then we are going to see the disadvantages. There are lots of disadvantages for half wave rectifier. So यहाँ पर कुछ हमने mention किए हैं. You can add more if you get somewhere in the books or रेफरेंस और टेक्स्ट बुक आप यहाँ पर ऐड भी कर सकते हो। उसके बाद हम कंपेयर करेंगे हाफ वेव एंड फुल वेव रेक्टिफायर। लास्ट टाइम लैब में से किसी ने एक ने फोटो भेजा था आपके ग्रुप पर कि कंपैरिजन ऑफ हाफ वेव एंड फुल वेव रेक्टिफायर। दैट इमेज इज वेरी इंपॉर्टेंट। If you have that, download that image, you can add here in the presentation और आप आपके नोटबुक में सेपरेटली लिखो, बिकॉज एग्जाम में क्वेश्चन आ सकता है कंपेयर हाफ वेव एंड फुल वेव रेक्टिफायर. सो एट दैट टाइम that image that you have taken from the laboratory will be helpful for you. Okay, now disadvantages of half wave rectifier, that uh, uh, you can have lots many disadvantages. That half wave rectifier, we can say first is a ripple factor is very high, that is 1.21. Then it has low efficiency, generally 40%. Low transformer utilization factor, that is 28%. Then AC power delivers to the load, it is only for the half cycle, therefore output is low. We are getting high ripple factor, that means output contains large amount of AC, so the filters are required to produce the DC current, which is the extra work, that extra filter we need to add here, and lots many. Okay, so few disadvantages are listed here on this PPT. You can add more if you want. And this is about the half wave rectifier. उसके बाद ये कुछ न्यूमेरिकल्स है. टाइम बीइंग जस्ट निग्लेक्ट दिस पार्ट, डोंट गो फॉर दिस न्यूमेरिकल सेक्शन, बिकॉज आपके एग्जाम में फॉर योर बैच न्यूमेरिकल पर ज्यादा कंसंट्रेट मत करो, न्यूमेरिकल ज्यादा नहीं आएंगे. इज इट ओके? समझ में आया?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Shall we go for the second one, that is full wave rectifier? फुल वेव रेक्टिफायर देखिए. Okay, so we are going to see the second type of rectifier, that is full wave rectifier. There are two types of full wave rectifier that we are going to study here. The first type of full wave rectifier is full wave rectifier by using center tap transformer, and the second full wave rectifier is a bridge rectifier. Now, as I explained the concept of center tap transformer during our lab session, इसका यहाँ पर डिटेल में दिया है what is mean by center tap connection and how the center tap transformer it is used for the rectification purpose. Now, as you can see on this screen, slide number 2, this is a center tap transformer that is available. Center tap connection is available at the secondary winding. Primary windings will be same as that of the regular transformer. Two connections, upper and lower, they get directly connected to the AC main supply, 230 volt and 50 hertz. At the secondary side, at the right hand side, we are having three connections. One at the upper side, another at the lower side, and one extra connection is there which is coming from exactly middle of the secondary winding of the transformer, and that middle point it is called as a center tap. So the this because of these three connections, center tap connection, this transformer is called as a center tap transformer. Now here the wire is adjusted such that uh, because of the center tap connection, there are two equal parts, one at the upper side and one at the lower side. Remember, this center tap connection is exactly at the center point at the secondary winding of the transformer. For example, suppose there are 100 turns at the secondary winding. So, the center tap connection will be placed at the winding number 50. So, this center tap connection will divide the secondary winding into two equal parts. कोई ऊपर नीचे नहीं होता, evenly distribute होता है into two similar parts. one at the upper winding, another at the lower winding. So this center tap transformer, it is used for the I'm sorry. The center tap connection, it is used for the full wave rectifier. Now this is a slide number 3 in front of you where you can see the full wave rectifier. Is the slide visible to you all?
Yes, ma'am.
So, primary windings as mentioned here, they are connected to AC input. AC इनपुट मतलब हमारा इनपुट में AC सिग्नल है, साइन वेव यहाँ पर इंडिकेट किया है, सिंगल साइन वेव दिखाया है with one positive half cycle and one negative half cycle. This sine wave acts as the input signal to the transformer. This is of course a step down transformer with center tap connection. So this is a construction I am talking about. So at the secondary winding, we have the three connections, respectively point A at the upper side, point B, terminal B we can say at the lower side, and a center tap connection coming exactly from the middle point, center point of the transformer secondary. As this is a type of full wave rectifier, there are two diodes need to be used, D1 and D2. The diode D1 is connected to the terminal A at the upper side with anode gets connected to point A. The cathode of diode D1 gets connected to one of the terminal of load resistor. The another terminal of load resistor is connected to the center tap connection. This is for upper section for the full wave rectifier. Same way we are having second diode D2 gets connected at the lower side with anode connection at terminal B, and cathode of diode D2 gets connected to the load register RL. That means at the load register we are having cathode connections of both the diodes D1 and D2. So cathode of D1 and D2, they are tied together, and from there a load register wire is taken out. The another terminal of RL, it is connected to the center tap connection. This is about the construction, how the circuit gets connected for the full wave rectifier. Across load register we get a DC output signal, जैसे यहाँ पर मेंशन किया है. Now we are going to see how the circuit functions for full wave rectifier. Now let's see the working. आपको कंस्ट्रक्शन समझ में आया, कैसे कंस्ट्रक्शन करना है? कंस्ट्रक्शन समझ में आया है ना? हेलो हेलो.
Ma'am, repeat. Thought में ma'am.
हेलो.
Hello. Yes, ma'am. Yes, ma'am.
Okay. So that was about this connections, how the connections are made for the uh, uh, full wave rectifier. Now coming back to the working. Now we are going to divide the working of full wave rectifier into two parts, two sections. One for the positive half cycle, we are going to see how the circuit behaves, and another part is during negative half cycle, we are going to see how the circuit behaves, how the circuit works. So let's start with the positive half cycle of the AC input signal. So as soon as positive half cycle appear across the secondary winding of the transformer, remember, look at this PPT. The terminal A, the upper terminal will be positive and the terminal B will be negative. As the terminal A is positive, the diode D1 will be forward biased and it acts as a closed switch. It acts as a on switch. So current will start flowing through positive terminal, that is terminal A, through diode, then as shown here with the blue color arrow, through the wires, and it will come back to the load register and the center tap connection. That means for positive half cycle, the diode D1, it is in a conducting state, on state. At the same time, for the positive half cycle, if you see the terminal B is negative, that means diode D2, it is in a reverse bias state, which acts as a open switch. That means the lower winding, it is in a open side. So no current is possible through the lower winding of the circuit. So we can say diode D1, it is in on state, and diode D2, it is in off state for positive half cycle of the input signal. This is the scenario for the first phase. Next, now look at the second PPT. When the negative half cycle appears across secondary winding of the transformer, now the terminal B will be positive, lower terminal is positive, and the upper terminal is negative. As terminal B is positive, the diode moves the forward bias state. Diode D2 will be in a forward bias state and diode D1 will be in a reverse bias state. As terminal B is positive, so current is going to flow from terminal B through diode D2 at the upper side through load register and towards the secondary, winding, towards the center tap connection. So for the negative half cycle, diode D2, it is in on state, whereas diode D1, it is in off state because it is in a reverse bias state, which acts as a open switch. Now in negative half cycle also, the direction of flow of current through load register is remains as the flow of current for the positive half cycle. For example, let's go back to the previous PPT. In this, for the positive half cycle, current flows through the load register from right side towards the left side. Look at the direction of arrow. Now in the second phase also, the current flows through the load register from right side towards the left side. That means whatever or irrespective of which diode is in on state, the flow of current through load register is same. Okay, and that is why we get both the half cycles and the output. So this is actually the complete circuit for we are getting positive half cycle when diode D1 is on and D2 is off, and negative half cycle which gets converted again into positive because diode D2 is on and D1 is off. So this is about the working of the full wave rectifier. This waveform, whatever the PPT is in front of you, this is very important. Input signal as it is sine wave with 0 pi positive, pi to 2 pi negative half cycle and so on. So in this we need to mention which diode is in on state and which diode is in a off state. इससे related question paper में question आएगा, explain the working and the construction of full wave rectifier with waveform. So you need to draw the circuit diagram, explain the construction, its working for the positive and negative half cycle, and These waveforms are important. You need to show which diode is in on state and which one is in a off state. ठीक है, current and voltage waveforms are same. Uh, we observe the output voltage across load resistor. यहाँ पर आप और एक पॉइंट दिखा सकते हैं, that is Vm is a maximum voltage for the input signal, whereas Vm minus Vd, it is a voltage across load resistor, where Vd defines the voltage drop across diode. That means 0.7 volts will lose. I mean input voltage उतना lose करेगा because this much is a barrier potential for the diode. So 0.7 volt तो diode के across ही चला जाएगा, and remaining voltage will be appear across the output load resistor. So these are the waveforms where you can show the input and output signals. Output में भी आप last waveform पर थोड़ा ज़्यादा concentrate करो, where actually VDC and IDC these lines are shown. V max and Imax points are already there. The middle dotted line indicates a DC and the DC voltage and current values. Okay, so these are the waveforms for full wave rectifier. Now coming back to the
Ma'am.
analysis part. जैसे yes.
Ma'am, that last graph was plotted with respect to omega t on the x-axis.
Instead of omega t, you can write there simply t. Time up instead of angular frequency, you can write the time.
बट मैम जो हाफ वेव रेक्टिफायर वाला जो आपने दिखाया था मैम, वहां पे जब रिपल फैक्टर वाला डेरिवेशन था तो उसमें भी ओमेगा टी के रिस्पेक्ट में ही था, तो मैम
Yeah. For the representation, you can either draw omega t or simple time. That doesn't matter. Omega t it is only for 2 pi f. Either you can replace 2 pi f or you can write omega t. तो उसमें कंफ्यूज मत हो.
ओके
ठीक
मैम.
है, तो यहाँ पर आप डायरेक्टली यू कैन राइट x axis as a t or you can write x axis as a omega t, whatever you feel comfortable. Either you can write sin 2 pi f t or 2 what you can write sin omega t, कुछ भी.
ओके मैम.
ठीक है. Okay, so this is about the analysis part we are going to see for the full wave rectifier. Here also we are going to derive the equations for the current, voltage, power, efficiency, ripple factor, peak inverse voltage for full wave rectifier. Again, concentrate only on the end equation. We don't require the derivation. Derivations are important only for the three factors, that is ripple factor, efficiency and the transformer utilization factor for the rectifier circuit. So यहाँ पर IDC find out करने के लिए as the name indicates, IDC stands for this is a DC load current. We are going to integrate 0 to pi, integration limits 1 upon pi, because this is a base Im sin omega t या फिर Im sin 2 pi f t. Integrate this. IDC value for full wave rectifier is 2 Im by pi. Remember, you can compare this with the half wave. Half wave के लिए IDC is Im by pi, whereas Im by pi plus Im by pi, it will be 2 Im by pi for the full wave rectifier. So simply we can write, for your understanding, ऐसे नहीं होता, half wave rectifier plus half wave rectifier is equal to full wave rectifier. ऐसे आप assume कर सकते हो, because at the output of full wave rectifier we get both the half cycles. So half wave plus half wave we can say full wave. So this is logically incorrect. This is only for your understanding कि आप उसको कैसे recite कर सकते हो, इसके लिए मैंने कहा. Otherwise just forget that, only concentrate on the equation. IDC for full wave rectifier is 2 Im by pi. IDC for half wave rectifier is only Im by pi. The same way, VDC for full wave rectifier is 2 Vm by pi. Full VDC for half wave rectifier is Vm by pi only. Only add here just term 2, because this is the full wave rectifier. Okay. Next is IRMS, that is root mean square. For half wave rectifier, IRMS was Im by 2, whereas in full wave rectifier, IRMS is Im by root 2. The root mean square voltage VRMS is equal to Vm by root 2 for full wave rectifier. For half wave rectifier, it was Vm by 2 only. Okay. Next, ripple factor. This point is important for full wave rectifier as well as half wave rectifier. Ripple factor, the basic equation will as it is. जो आपने half wave में use किया था ना, the same equation we are using here for full wave also. Only there will be change in the parameters inside that. So ripple factor is VRMS square minus VDC square upon VDC, and numerator का raised to half लेना है because it is root mean square. So this equation, ripple factor का basic equation, it is same for half wave and for the full wave. Only here substitution it is different. VRMS for full wave rectifier is Vm by root 2 उसका square minus VDC for full wave rectifier is 2 Vm by pi उसका square raised to half, that is its root, upon VDC is 2 Vm by pi. वो फुल वेव रेक्टिफायर के सारे सब्स्टिट्यूशन इसमें डालो रिपल फैक्टर के बेसिक फंडामेंटल इक्वेशन में, देन check which term gets deleted. At the end, we get the ripple factor R for full wave rectifier in percentage is 48%. That means the ripple factor R is much less than the ripple factor of half wave rectifier. Half wave rectifier का ripple factor कितना था? It was 121% या फिर 1.21. The ripple factor for the full wave rectifier is only 0.48, that is 48%. That indicates the quality of DC output voltage in full wave rectifier is much better than the quality of half wave rectifier. Remember, the ripple factor we always want at the lower side. We always want very close to the zero. तो रिपल फैक्टर जितना कम होगा उतना सर्किट अच्छा होगा, उतना हमारा डीसी कंटेंट आउटपुट में ज्यादा होगा. सो रिपल फैक्टर, दिस इज अ कंपैरिजन पॉइंट इन बिटवीन हाफ वेव एंड फुल वेव, या फिर दिस इज वन ऑफ द एडवांटेजेस ऑफ फुल वेव रेक्टिफायर इज ripple factor is 48%, which is very low in full wave rectifier. The amount of DC content at the output is very high. The amount of AC content is low. This is advantage of full wave rectifier. Then DC output power PDC is equal to, we can write V square DC upon RL. AC input power PAC is equal to Im square by 2 into RL in bracket. Then efficiency. Yes, this point is important for full wave rectifier. Efficiency, the main equation, the basic equation remains as it is. Efficiency of any rectifier circuit is defined as it is a ratio of output power upon input power. So efficiency is equal to PDC upon PAC. PDC is equal to I square DC into RL. PAC is equal to I square RMS into RL, where I square RMS, this is the term related to the input side. So we can write by deleting the factors RL from numerator and denominator, we get efficiency is equal to I square DC upon I square RMS. अभी IDC और IRMS के factors उसमें डालो, substitution डालो in this equation, and at the end we get the efficiency for full wave rectifier in percentage is 81.2%. We always want the higher efficiency very close to the 100%. So rectifier efficiency for full wave rectifier is much more, almost double than the half wave rectifier. So this is the advantage of full wave rectifier, that efficiency is more. ओके, सो ये एक पॉइंट एडवांटेज का है, ये एग्जाम में भी आ सकता है। देन पीक इनवर्स वोल्टेज फॉर द फुल वेव रेक्टिफायर इज 2 vm, so this is actually twice of the input voltage the diode should withstand with. Diode should be capable for handling this much voltage in the reverse bias state. Peak inverse voltage का भी definition same ही है. This is a maximum reverse voltage handling capacity of the diode. For half wave rectifier, PIV was Vm. For full wave rectifier, the PIV is twice of Vm. एक्चुअली ये इसका एक डिसएडवांटेज हो गया फुल वेव रेक्टिफायर का, कि हमें डायोड का इतना कैपेसिटी चाहिए कि वो डबल वोल्टेज हैंडल कर सके. ओके, then output frequency of full wave rectifier is double than the input frequency because we get both the half cycles at the output, जैसे यहाँ पर स्क्रीन पर दिखाया है. आउटपुट फ्रीक्वेंसी 0 to pi, pi to 2 pi, so f out is equal to 2 into f in. Then advantages and disadvantages of full wave rectifier. Again this point is important. Advantages तो बहुत सारे हैं. That means the first advantage is the circuit has low ripple factor as compared to the half wave rectifier. Circuit has better efficiency. Transformer utilization factor हमने नहीं देखा, but still you can write it has a better transformer utilization factor. Then in full wave rectifier, we can say we get higher amount of DC present, lower amount of AC present. So whatever the signal we expect at the output across load register contains more amount of DC. This advantages you can add here in full wave rectifier with the reference and the textbooks. Now disadvantages. Disadvantage of full wave rectifier is it is difficult to locate a center tap connection at the secondary winding. And another disadvantage you can write here as in full wave rectifier 2 diodes are required. So 2 diode means एक का cost unnecessarily increase हो गया, circuit थोड़ा बड़ा हो गया. So this circuit is little bit costlier because center tap transformer is required, one more diode is required. So circuit का थोड़ा cost increase हो जाता है, circuit will become more bulky and it requires more space. So these are the disadvantages of full wave rectifier. Okay. So the third type of rectifier, just a minute, let me paste here the link for today's attendance. Just a minute. I hope everyone can access the chat box.
Yes, ma'am.
Yes, ma'am.
Yeah, okay. Please check in your chat box whether the link is available. Can you
Yes, ma'am.
see?
No, ma'am, not available.
Yes, ma'am.
Yes.
Ma'am.
Okay, you can mark your attendance for this lecture. This link will be active till 6:30 today. So before that, please
Ma'am,
mark
अभी
your
link कहाँ? Link.
लिंक है ना चैट बॉक्स में. लेक्चर के चैट बॉक्स में चेक करो, लिंक इज गिवन एंड इट इज वर्किंग.
got it.
Ma'am, the lecture is over.
No. Just wait. I'm sharing the screen.
एक्सक्यूज मी मैम।
Yes.
मैम मैंने गलती से पीएनआर में 1-4 और नहीं लिखा।
रोल नंबर तो ठीक तरह से लिखा है ना?
हाँ मैम, रोल नंबर 17 लिखा है। पीएनआर मैम 1-4 नहीं लिखा था। 211-411 1-4 रह गया।
ठीक है, रोल नंबर के हिसाब से मैं देखती हूँ।
ठीक है, सॉरी मैम।
मैम मेरा भी सेम हुआ है।
Excuse me,
4
ma'am.
0 4 हो गया है।
अरे आप रोल
Ma'am, I
नंबर
didn't receive the link in the chat box.
why? Chat box is available to you all, I hope.
Yes, ma'am. Ma'am, but I didn't receive the link.
कैसे हो सकता है?
अनऑफिशियल पे भेज दिया, अनऑफिशियल पे देख लो।
Yeah. Someone please post that link on unofficial group and you can just fill attendance from your that.
Okay, ma'am.
Okay. So type of rectifier we're going to see is a bridge rectifier. A bridge rectifier, this is a type of full wave rectifier, remember, where जिसका सर्किट का efficiency of course ज्यादा होगा. So half wave rectifiers are rarely used only for the study purpose. Otherwise, wherever the conversion is required from AC to DC in all the circuits, the full wave rectifier, bridge rectifiers are used. So bridge rectifier, it is a full wave rectifier. As the name indicates, bridge means there are the diode connected in such a way that they form the bridge, and so the name it is given as a bridge rectifier. In the previous step, we have seen the transformer which was used as a center tap transformer with the two diodes in a full wave. Now to eliminate the use of the center tap transformer, which is rarely used, we go for the bridge rectifier. So in a bridge rectifier, remember a regular normal transformer जैसे हमने half wave में use किया था, वैसे ही transformer use होता है, ना कि center tap वाला transformer. So this is the advantage of bridge rectifier. The center tap transformer is not required, so that ultimately reduce the cost. Again, someone has unmuted. Hardik or so bridge rectifier, here the number of diodes are 4 actually. So the number of diodes जो पहले 2 थे half wave में, now the number has been increased to 4, double हो गए, and the transformer जो था वो regular transformer हो गया. Okay, so this is a bridge rectifier circuit where actually we require 4 diodes. Now look at this circuit diagram which is in front of you in the slide number 3. So diode D1, look at the connections how they are made. Diode D1, then the anode upper side में connected है. Then diode D2, D1 and D2, they are in the same orientation, whereas diode D3 and D4, they are in a opposite orientation. आपको पता है ये सर्किट डायग्राम कैसे ड्रॉ करना है, with how much, what indication you draw this circuit, और आपको कैसे conceptually ये ड्रॉ करना है पता है आपको?
जिधर करंट जाए उधर पॉजिटिव लगाना है टर्मिनल, करंट की डायरेक्शन पे डायोड लगेगा.
Just a minute, I will show you here with the help of whiteboard. सर्किट को ड्रॉ कैसे करते हैं.
Excuse me, ma'am.
Is the screen?
Excuse me, ma'am.
Yeah.
Ma'am, I have an issue with my Outlook password. I had told you about it yesterday. So kindly mark my attendance. It's 38, ma'am. I cannot log in with the browser.
With the help of that link also, you are not able to mark your attendance.
No, ma'am, because I had to log in first and I had forgotten my password. So I talked to you about it yesterday only, ma'am.
Yes, you just do one thing. You would send me your details on the group, not personal
Yeah,
chat.
I did it, ma'am. I did it.
Right.
I just want to say that mark my attendance. It's 38, ma'am.
Sorry. What?
My roll number is 38, ma'am.
Okay, okay. I will mark your
Yeah.
attendance. Don't worry. Okay. So
Thank
I
you.
hope this whiteboard is visible to you all.
Hello.
Yes, ma'am.
बस होली
Okay.
खत्म है।
So okay, fine. So we are going to draw here the bridge rectifier circuit. I will show you here only कि आपको logic कैसे apply करना है, so that our bridge should be connected in such a way that कि हमारे दो डायोड जो है वो at a time on state में चाहिए और दो डायोड्स at a time off state में चाहिए. So this is a transformer.
Ma'am, your screen is freeze.
स्क्रीन नहीं दिखाई दे रहा है. ये देखो अभी देखो थोड़ा सा
Yes, ma'am. दिख रहा.
मैम दिख रहा है.
जूम करके देखो अगर आपकी साइड से नहीं दिख रहा है तो. ट्रांसफॉर्मर अभी दिखा, ये रेगुलर ट्रांसफॉर्मर.
Ma'am, the screen is completely blank. Yes, ma'am.
आपकी
यस मैम दिख गया मैम.
दिख रहा है ना.
यस मैम.
Ma'am.
No, ma'am.
मैम बहुत छोटा था मैम, जूम करना पड़ेगा थोड़ा.
हाँ जूम करो. जिनको नहीं देख रहा है ना वो थोड़ा स्क्रीन हिलाओ आपका. शायद वो किसी कॉर्नर में चला गया हो. मेरे सामने तो है मेरा सर्किट डायग्राम में ड्रॉ कर रही हूँ. एज आई एम ड्रॉइंग आई एम गेटिंग कि मैं कैसे ड्रॉ कर रही हूँ अपनी स्क्रीन पर. आप थोड़ा सा आपका स्क्रीन एडजस्ट करो ना.
Yes, ma'am. Yes, ma'am. Visible.
शायद किसी
Now it's visible. Now it's visible.
विजिबल है
Yes, ma'am.
या मैंने अभी ट्रांसफॉर्मर ड्रॉ किया है. विजिबल है.
यस मैम.
थोड़ा सा देखो.
यस मैम.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
ओके. अभी मैं ब्रिज कनेक्शन ड्रॉ करने वाली हूँ कि कैसे ब्रिज को डायोड को कैसे कनेक्ट करना है. सी पहले हम 4 डॉट्स लेंगे एट द 4 एंड. पर्पसली मैंने रेड कलर का यहाँ पर पेन यूज किया है ताकि हमें समझ में आए कि हम डायोड को कैसे यूज करने वाले. नाउ रिमेम्बर इन दिस bridge rectifier circuit we are going to connect the diodes in such a way that at positive half cycle we want 2 diodes in a conducting state. At that time remaining 2 diodes should be in a non-conducting state. उस समय दो डायोड्स ऑन रहेंगे. नाउ इन नेगेटिव हाफ साइकिल पहले वाले जो ऑफ थे वो ऑफ होने चाहिए और पहले वाले जो ऑन थे वो ऑफ होने चाहिए. That means in every half cycle 2 diodes should be on and 2 diodes should be in a off state. यहाँ तक मैंने अभी ट्रांसफॉर्मर ड्रॉ किया. सेकेंडरी पर हम ब्रिज सर्किट इस तरह बनाएंगे कि हमारे दो डायोड्स एट अ टाइम ऑन स्टेट में चाहिए along with the load resistor. Now look at the diagram very carefully how I draw the diode orientation, how I draw the diode connection. Now the upper side, for example, let upper terminal is A and the lower terminal is B. Okay. Now start from the upper terminal. यहाँ पर हम डायोड D1 पहले ड्रॉ करेंगे. Look at at the diode direction, how I am drawing. Let this is diode D1. D1 सबको दिखाई दिया? Diode D1.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
तो जब टर्मिनल पर वाला पॉजिटिव होगा, पॉजिटिव हाफ साइकिल के लिए, तो करंट कैसे फ्लो होगा? यहाँ से ऐसे फ्लो होगा, फिर यहाँ से ऐसे फ्लो होगा D1 से, और यहाँ तक आ जाएगा. फॉर एग्जाम्पल इसको हम देते हैं पॉइंट C. तो फॉर पॉजिटिव हाफ साइकिल डायोड D1 इज इन अ फॉरवर्ड बाय स्टेट. ठीक है, अभी पॉइंट C तक आ गया, तो हम क्या करेंगे? पॉइंट C एंड दिस, लेट दिस पॉइंट इज पॉइंट D. यहाँ पर हम लोड रजिस्टर कनेक्ट कर सकते हैं. ठीक है, तो करंट कैसे बढ़ा? इस साइड से यहाँ आ गया, देन इधर आ गया, एंड इट विल कम टू द पॉइंट D. तो करंट ऐसा हमारा फ्लो हो रहा है फॉर पॉजिटिव हाफ साइकिल. नेक्स्ट, पॉइंट D और लोअर टर्मिनल को हम इस तरह कनेक्ट करेंगे कि हमारा दूसरा वाला जो डायोड है ना, वो भी ऑन स्टेट में चाहिए. तो आई विल यूज हियर अनदर. This is diode D1, upper one, and the lower one is diode D2. ठीक है, तो पॉजिटिव हाफ साइकिल में हमारे दो डायोड्स ऑन है, D1 एंड D2. अभी पॉइंट D से डायोड D2 में गया, फिर यहाँ ऐसे आया करंट, और ये फिर से नेगेटिव साइड में गया. So this is the direction of the current for positive half cycle when diode D1 and D2 are in a forward bias state. अभी उस टाइम हमें डायोड D3 एंड D4 को ऐसे कनेक्ट करना है कि वो रिवर्स बायस स्टेट में जाने चाहिए, या फिर डायोड D3 एंड D4 को हमें ऐसे कनेक्ट करना है कि वो नेगेटिव हाफ साइकिल में फॉरवर्ड बायस में चले जाने चाहिए. नाउ सी हाउ आई ड्रॉ दिस connection. Now what happens for the negative half cycle? Negative half cycle के लिए the lower terminal will be positive, the lower terminal is positive and the upper terminal is negative. Now current कैसे flow होगा? ऐसे flow होना चाहिए lower side से, क्योंकि ये terminal positive है ना, तो ऐसे flow होगा current इस direction से. Now we need to connect a diode in such a way that it should be forward biased for negative half cycle. So let this is a diode T3 which is forward bias. करंट ऐसे फ्लो हो रहा है यहाँ से through diode D3. It is coming at point C. It is flowing current in this direction. It will come back to point D. अभी डायोड D4 को कैसे कनेक्ट करना है कि वो
पॉजिटिव
अभी
और नेगेटिव.
मोड में चला जाए. हाँ, तो दिस डायोड D4 should be connected in such a way that कि यहाँ पर जो हमारा करंट आया ना, तो अभी यहाँ से ऐसे फ्लो होना चाहिए, and it will come back to the negative terminal which is the upper terminal. Okay, so for positive half cycle, diode D1 and D2 are forward biased, or we can say they are on, and diode D3 and D4 they are reverse biased, that means they are off. For we can say negative half cycle, कौन से डायोड्स ऑन है नेगेटिव हाफ साइकिल में? नेगेटिव हाफ साइकिल में टर्मिनल बी पॉजिटिव है ना, तो डायोड होंगे
D3 और D4।
यस, D3 एंड
Yes,
D4 आर ऑन, है ना, एंड उसी टाइम डायोड D1
और
एंड
D2 ऑफ स्टेट।
D2
and D2 will
Off.
be on.
ऑफ स्टेट।
इन ऑफ स्टेट, दैट इज रिवर्स बायस। ऑन है मतलब फॉरवर्ड बायस है और ऑफ है मतलब रिवर्स बायस। ठीक है, ये समझ में आया? पॉजिटिव हाफ साइकिल के लिए टर्मिनल
ma'am.
ए पॉजिटिव है, करंट जो रेड कलर से दिखाया है ना वैसे करंट फ्लो होगा यहाँ से D1 से पॉइंट सी से लोड रजिस्टर से, यहाँ पर RL मेंशन कर लेते हैं तो आपको समझ में आएगा। RL दैट इज लोड रजिस्टर। RL, ठीक है, तो RL थ्रू पॉइंट D पर आएगा, D से D2 की तरफ जाएगा क्योंकि D2 फॉरवर्ड बायस में है, वो D4 की साइड में नहीं जाएगा, ऊपर नहीं जाएगा, नीचे की डायरेक्शन में आएगा। रिमेंबर दिस, एंड इट विल कम टू द नेगेटिव टर्मिनल दैट इज लोअर साइड। फॉर नेगेटिव हाफ साइकिल क्या होगा? टर्मिनल बी विल बी पॉजिटिव, द करंट विल फ्लो थ्रू डायोड D3 क्योंकि उस समय डायोड D2 रिवर्स बायस में है, तो D3 से फ्लो होगा थ्रू लोड रजिस्टर, इट विल कम टू द पॉइंट D एंड इट विल गो टू द डायोड D4 से अपर साइड में पॉइंट A की साइड में चला जाएगा। So if you see here, for both the half cycles, the direction of flow of current through load resistor is same. RL से दोनों साइड में राइट से लेफ्ट ही करंट फ्लो हो रहा है. It is flowing from point C to point D. Therefore, for both the half cycles, we get this kind of signal for positive half cycle and for the negative half cycle. Okay, so bridge rectifier, it is a full wave rectifier which converts both the half cycles of the input AC signal into equivalent output signal, positive side. Now there are disadvantages of full this bridge rectifier circuit that हमें दो डायोड एक्स्ट्रा चाहिए, along with diode D1 and D2 हमें और दो डायोड्स चाहिए D3 and D4, जिससे सर्किट का कॉस्ट अननेसेसरीली इंक्रीज हो जाता है. But the advantage is that here we don't require center tap transformer connection. तो यहाँ पर रेगुलर ट्रांसफॉर्मर चलेगा which reduces the cost. Okay, so this has been explained in that theoretical part जो हमारे PPTs में है. एंड आफ्टर दैट एनालिसिस जो है इसका ना हाफ वेव फुल वेव रेक्टिफायर ब्रिज का, दिस इज क्वाइट सिमिलर टू द सेंटर टैप ट्रांसफॉर्मर. लिटिल पॉइंट्स, सम पॉइंट्स आर डिफरेंट दैट वी विल डिस्कस इन द नेक्स्ट टाइम. ओके, यहाँ पर आपको समझ में आया द वर्किंग ऑफ ब्रिज रेक्टिफायर एंड द वर्किंग ऑफ फुल वेव रेक्टिफायर यूजिंग सेंटर टैप ट्रांसफॉर्मर. इसका अगर आपको स्क्रीनशॉट लेना है तो यू कैन टेक द स्क्रीनशॉट ऑफ दिस स्क्रीन, बिकॉज आई डोंट थिंक कि ये हमारे रिकॉर्डिंग में रिकॉर्ड होता है, क्योंकि रिकॉर्डिंग में सिर्फ पीपीटी से रिकॉर्ड होंगे, शायद व्हाइट बोर्ड रिकॉर्ड नहीं होता. आई जस्ट हैव सम, शायद वो नहीं होता. So those who want, you can take the screenshot of this recording, this whiteboard, and for your reference. Otherwise, all this information is present in the PPTs also. This is only for understanding कि हमें कौन से वे से सोचकर सर्किट डायग्राम बनाना है. So if you remember logically कि for positive half cycle this should be on, this should be off, then your circuit diagram will be correct. अगर आप उसको बाय हार्ट करोगे तो आपका सर्किट डायग्राम शायद कुछ कंफ्यूजन की वजह से एग्जाम में शायद गलत हो सकता है. बट इफ यू थिंक लॉजिकली योर सर्किट डायग्राम ऑलवेज बी इन अ करेक्ट वे. Okay, so I think we stop here today, and on Saturday we'll complete this rectifier and the clipper and clamper part. Okay, that will end our unit number 2. Probably Saturday या फिर और एक लेक्चर हमें लगेगा, तो will see कि हमारा अभी इस हफ्ते कितना सिलेबस होता है. अदरवाइज नेक्स्ट वीक में हम यूनिट नंबर 3 से स्टार्ट करेंगे. ओके, ओके. Very nice. Okay, so shall we leave now?
Thank you.
Okay. So I hope everyone has marked the attendance except roll number 38. Okay. So we'll see on Saturday 11:30, and we'll complete the next point, that is clipper and clapper, and the rest some part of this bridge rectifier. We haven't seen the comparison of the three circuits, so we'll see on Saturday. Okay.
कीजिए
Okay.
Okay.
Okay. Thank
Thank you,
you.
ma'am.
Yeah. Bye.
Thank you,
Take
ma'am.
care.
Thank you, ma'am.
Bye.
Thank you, ma'am.
Thank you, ma'am.